Tonight, before you close your eyes, consider a question so unsettling that it has haunted the greatest scientists for more than 70 years. Look up at the night sky. Every tiny star you can see is a sun. Around many of those suns are planets. Around many of those planets, there could be oceans, continents, skies, storms, maybe even civilizations looking back into space exactly as we are. Now here's the disturbing part. The observable universe contains roughly 2 trillion galaxies. Each galaxy holds millions or even hundreds of billions of stars. Altogether, the universe contains more stars than there are grains of sand on every beach on Earth. If life is even remotely common, if intelligence can emerge from chemistry, if civilizations can survive long enough to build technology, then many scientists would expect the universe to be overflowing with life. Not just 1 or 2 alien civilizations. Perhaps millions. Or perhaps far fewer, we simply don't know. Some should be thousands, even millions of years older than us. Civilizations so advanced that our greatest achievements would look like cave paintings beside a modern smartphone. And yet, the universe is silent. No spacecraft. No messages. No cities orbiting distant stars. No unmistakable signs that anyone has ever been here. It's as if the greatest stage ever built is completely empty. Or perhaps it isn't. Maybe we're searching in the wrong way. Maybe they're hiding. Or maybe something happens to every civilization before it ever gets the chance to explore the stars. A possibility so terrifying that it could determine humanity's future. This mystery has a name. The Fermi Paradox. And by the end of this story, you may never look at the night sky the same way again. The story begins not in a laboratory filled with glowing computers, but during an ordinary lunch in the summer of 1950. Physicist Enrico Fermi sat with a group of fellow scientists at Los Alamos National Laboratory. They were discussing recent reports of flying saucers and joking about a newspaper cartoon when Fermi suddenly fell silent. He reportedly made a few quick calculations. Then he looked up and asked 4 words that would echo through history. Where is everybody? What began as a joke quickly became a serious question. Fermi crystallized a contradiction that few had fully appreciated. The Milky Way is unimaginably old, roughly 13.5 billion years. Our own sun didn't even exist until around 4.6 billion years ago. Humanity, by comparison, has only been around for about 300,000 years. Modern civilization? Barely 10,000. Everything else remains unchanged until. Then someone should already be here. Earth might have been visited millions of years before humans ever existed. The moon might contain ancient artifacts. Asteroids could hold abandoned machines. The night sky should glow with unmistakable signs of advanced engineering. Instead, every telescope points into darkness. Every radio antenna listens to silence. Every mission into space returns with extraordinary discoveries. Except the discovery many hoped to make. Another civilization. For centuries, humanity had only one example of a planet capable of supporting life. Earth. That made it impossible to answer one of the biggest questions in science. Was our world a miracle? Or was it simply one of countless living planets scattered across the galaxy? Then, in the 1990s, everything changed. Astronomers discovered the first planet orbiting a sun-like star beyond our solar system. At first, it was just one. Then another. And another. Today, scientists have confirmed thousands of exoplanets, with many thousands more waiting to be verified. Some are giant gas worlds larger than Jupiter. Others are frozen wastelands. Some orbit 2 stars, creating skies with twin sunsets. And a small but growing number lie within what's known as the habitable zone, the region around a star where temperatures could allow liquid water to exist. Suddenly, Earth no longer looked unique. Planets themselves looked common. The Milky Way alone is now estimated to contain hundreds of billions of planets. Many scientists believe that billions of those could potentially have conditions suitable for life. Imagine standing on a beach. Pick up a single grain of sand. Now imagine that grain represents one potentially habitable planet. The beach would stretch farther than you could ever walk. Surely, somewhere among those countless worlds, life may have appeared. But here's where the story becomes even stranger. Life appeared on Earth remarkably quickly. Our planet formed about 4.5 billion years ago. For its first few hundred million years, Earth was a violent hellscape. Giant asteroids constantly slammed into its surface. Volcanoes covered the landscape. Oceans boiled. The atmosphere was toxic. It looked completely uninhabitable. Yet as soon as conditions became stable enough, the earliest evidence of life appears soon afterward. The oldest evidence suggests that microscopic organisms existed more than 3.5 billion years ago, and some research hints it may have begun even earlier. In cosmic terms, life didn't seem reluctant to appear. It appeared relatively quickly in geological terms. That observation carries an extraordinary implication. If life began quickly here, maybe it begins quickly everywhere. Perhaps wherever liquid water, the right chemistry, and enough time exist, life is more likely to emerge. But evolution tells a different story. For over 3 billion years, Earth belonged almost entirely to simple, single-celled organisms. No forests. No dinosaurs. No mammals. No humans. Just tiny microscopic life drifting through ancient oceans. Then, about 540 million years ago, something astonishing happened. In what scientists call the Cambrian explosion, life suddenly diversified at an incredible pace. Complex animals with eyes, shells, limbs, and entirely new body plans appeared in what was, geologically speaking, the blink of an eye. Even today, researchers still debate exactly why it happened. But one thing became clear. Simple life may be common. Complex life may be much harder. And intelligent life harder still. Think about Earth's history. If you compressed the entire 4.5 billion year history of our planet into a single calendar year, life would appear in early spring. Complex animals wouldn't arrive until mid-December. Dinosaurs would dominate only during the final week. Humans? We wouldn't appear until the last few minutes before midnight on December 31st. Modern civilization would occupy less than the final second. Everything humanity has ever built. Every empire. Every language. Every invention. Every work of art would exist inside the smallest fraction of Earth's history. That realization changes the question entirely. Maybe life isn't the rare part. Maybe intelligence is. Perhaps countless planets are covered in microbial oceans. Perhaps alien bacteria are incredibly common. Perhaps entire galaxies are filled with simple organisms that never evolved beyond microscopic life. If that's true, then intelligent civilizations like ours could be extraordinarily rare. This idea became known as the rare Earth hypothesis. It doesn't argue that life is impossible. It argues that the chain of events leading from simple cells to technological civilizations may require such an unlikely combination of circumstances that it almost never happens. A stable star. Possibly a protective magnetic field. Plate tectonics. Perhaps a large moon helping stabilize the planet's tilt. The right chemical ingredients. Billions of years without complete sterilization. And evolutionary breakthroughs that might depend as much on chance as on necessity. Miss just one step, and intelligence may never appear. It's a fascinating possibility. But there's an even darker one. What if intelligent civilizations aren't rare at all? What if they appear across the galaxy, only to disappear before anyone ever hears from them? Because hidden somewhere between the birth of life and a civilization capable of reaching the stars, there may be an invisible barrier. A barrier that few civilizations may survive. Scientists call it the Great Filter. The Great Filter is one of the most chilling ideas ever proposed in science. because it suggests that somewhere along the path from lifeless rock to a civilization capable of exploring the stars, there may be an obstacle so devastating that almost every civilization fails to overcome it. Imagine evolution as a series of locked doors. The first door is the creation of life itself. The second is the evolution of complex cells. Then multicellular organisms. Intelligence. Language. Technology. Industrial civilization. Space exploration. Interstellar travel. Any civilization hoping to reach the stars would have to unlock every single door. Miss just one, and the journey ends forever. The terrifying question isn't simply whether the Great Filter exists. Some scientists argue that the universe's silence may point toward one. The real question is, where is it? Is it behind us? Or is it still waiting ahead? If the Great Filter. Imagine visiting a wildlife reserve. You watch the animals from a distance. You study their behavior. You avoid interfering unless absolutely necessary. Not because you dislike them, but because your presence would permanently change the way they develop. Now imagine an alien civilization looking at Earth the same way. Perhaps they discovered our planet millions of years ago. They watched the first single-celled organisms emerge from ancient oceans. They witnessed the rise and fall of the dinosaurs. They observed our ancestors learning to use fire, invent language, build civilizations, and eventually send rockets into space. And through all of it, they never revealed themselves. This idea is known as the zoo hypothesis. It suggests that advanced civilizations intentionally avoid contact with younger species, allowing them to evolve naturally until they reach a certain level of maturity. It sounds like science fiction. But when anthropologists study isolated tribes on Earth, they often follow a similar principle. Contact can unintentionally destroy cultures, spread disease, or permanently alter their development. Perhaps, on a cosmic scale, humanity may be the isolated tribe. If that's true, then first contact isn't impossible. It may simply be, not yet allowed. Of course, there's another explanation. Maybe advanced civilizations become so different from us that we no longer recognize their existence. Think about humanity today. In just a few decades, we've gone from room-sized computers to artificial intelligence capable of generating text, images, and solving complex problems in seconds. Technology evolves faster every year. Now imagine another million years. Would biological beings even remain biological? Perhaps they could upload their minds into machines. Perhaps they could exist as digital consciousness spread across entire star systems. Perhaps they communicate using methods we haven't yet discovered or technologies beyond our current understanding. We continue listening for radio waves, while they abandoned radio hundreds of thousands of years ago. It's like searching the ocean for ships using smoke signals. Our methods may simply be outdated. Even so, humanity continues searching. Projects like SETI have spent decades scanning the skies for artificial signals. Powerful radio telescopes listen day and night. Space telescopes search distant worlds for atmospheric gases that might indicate life. Scientists even look for signs of massive engineering projects, structures so enormous they would partially block the light of their host stars. So far, nothing definitive. There have been intriguing mysteries. In 1977, a radio telescope detected a powerful signal so unusual that astronomer Jerry Emmon wrote one word beside it. Wow! The famous wow! Signal lasted just 72 seconds. It has never been conclusively explained. Despite decades of searching, it has never repeated. Was it a natural phenomenon? A coincidence? Or the briefest whisper from another civilization? No one knows. And perhaps that's what makes the Fermi Paradox so compelling. Every answer creates even bigger questions. Maybe we're alone. Maybe intelligent life is extraordinarily rare. Maybe civilizations destroy themselves before reaching the stars. Maybe they're hiding. Maybe they're watching. Or maybe the universe is filled with life beyond our imagination, and we simply haven't learned how to see it yet. Then there's one final possibility. Perhaps humanity is among the very first intelligent civilizations ever to emerge. The universe is nearly 14 billion years old, but many stars capable of supporting life are expected to burn for trillions of years. Compared to that future, the cosmos may still be in its infancy. If that's true, then the silence isn't evidence of failure. It could be evidence that the greatest chapter of cosmic history hasn't happened yet. Maybe future civilizations will look back at humanity the way we look back at the first organisms that crawled onto land. Not as the end of the story, but as the beginning. The Fermi Paradox doesn't merely ask where everyone is. It asks what kind of civilization we choose to become. Will humanity survive its greatest challenges? Will we overcome our own great filter? Will we one day spread beyond Earth and carry life into a silent galaxy? Or will we become another civilization that vanished before anyone knew it ever existed? Tonight, when you step outside and look up at the stars, remember this. Every point of light is another possible world. Some may be lifeless. Some may be waiting for their first spark of life. Some may hold civilizations that disappeared millions of years ago. Some may be looking back at us with the same questions we ask about them. The strangest part isn't that we haven't found anyone. The strangest part is that, in a universe so unimaginably vast, humanity could be holding one of the rarest gifts in existence, the ability to ask the question at all. And somewhere, hidden among those countless stars, the answer is waiting.